Look through question 23, which is also a challenging question, and I know some students did get it incorrect. Okay, so first of all, let's read through it. A tertiary bromoalkane indicated here reacts with aqueous NaOH. The mechanism has the reaction pathway shown. Okay, which point in the diagram is correctly identified? And then you've got your four options there. Now, first of all, let's look at background information here. We're talking about a tertiary bromoalkane. Remember, tertiary effectively means that this carbon here that's connected to the carbon, that's connected to the halogen there, the bromine, that there are three carbons attached to it. Okay, that's what tertiary means. Now, before we move on, you should be aware that the tertiary ones will take part in the SN1 type of reaction. That's SN1 type of reaction, and that's pretty important. Okay, and if I just complete the picture here, this would, let's say this is CH3 there, and this is CH3 here, and this is CH3 here. Okay, now the reason why this is called an SN1 style of reaction is because only this molecule is actually involved in the first step. This is the only thing involved in this first rate determining step. In other words, we remember that this is going to have a, this is basically negatively charged in relation to this. This is going to break off, essentially, and that's going to form a Br- ion. And then we're going to form our carbocation as a result there. Okay, we're going to form that. But this happens on its own. In other words, the NaOH, the OH here, is not involved in this step. This molecule breaks up on its own. So if we think about what we've just spoken about, this is the slow step, okay, and it's happened independently of the sodium hydroxide. It's just happened on its own, and we've formed the carbocation here, okay? So if we kind of follow this reaction pathway, this is where we've got to right now. We've got to this point Y, okay? We've arrived at here after the slow step. So we've actually got to our answer right now, although I will continue explaining. We've got to our answer. Y is indeed the point at which we form this carbocation. So the answer is going to be C here, but I'll continue talking through the rest of the question. So what's going to happen next in what we call the fast step? First of all, let me illustrate that fast step. It's going to be this next bit here, okay? So this can be considered to be the fast step, the second part of the reaction. Okay, and let's just quickly talk through why this step has no influence on the reaction rate. Well, if you can see that the value here at the top of this hump here is higher than the value here. In other words, it's very, very key that this amount of energy is attained in order for the reaction to take place. In other words, it's this first step here, this hump of energy that it needs to get over, that determines the rate, because this hump is lower than the hump here. So that is why it's only this first step here is actually determining the rate of this reaction. So what happens? So then we've got the hydroxide ion moving in then, and effectively forming the bond here with the carbocation. I'm not writing out the mechanism properly here, but I'm just trying to illustrate what's going on. So this is the second step, the fast step that's going on when this then locks on to the carbocation. And as a result, you're going to be forming an alcohol here, okay? We don't know what alcohol it is. According to, they haven't told us exactly what we're dealing with here, but I've used this as an example. Right, so now we've got to rule out why some of these are incorrect, okay? Now, first of all, it's probably just worth remembering that because this is SN1, in other words, it's only involving this molecule itself in that first rate determining step, there is no transition state. So this state here and this state here, these are both indicating transition states. These can't be correct, okay? because there is no transition state, because this is an SN1 mechanism. You'll only get your transition state in the SN2 mechanism, okay? So B and D are ruled out for that reason. Now, the reason why A is ruled out is saying that X here, which is this moment here in this reaction profile, is the formation of the carbocation, okay? But the formation of the carbocation is after the first step, the slow step. So that would be here, not here, okay? This just represents basically the activation energy of allowing that carbocation to form. You've got to get over that hump in order to actually form your carbocation. But the carbocation will actually be formed at this point, Y, okay? So hopefully that explains why A, B, and D are incorrect, and C is your correct answer here.